Geometry, Unit 1, Review. For number 1, it wants us to provide another name for line R. Line R has points X and T on it. So it can also be named line XT or TX. As long as you have that line symbol on top, you're fine. Another name for line N, since there's several points on there, as long as you pick any combination of 2, you're fine, and put the line symbol. So I could say WX. I could say VW. I could say VY. I could say XY. So there are a lot of combinations for another name. Number 3, name 4 points that are coplanar with point W. So again, coplanar means they're on the same plane. So we would have V, X, Y, and Z. They're all on that little rectangle paper looking piece. All those points are on there with W. T is not on the plane. For number 4, we're naming the intersection of lines R and N. So here's line R. And here's line N. So they intersect right here at X. Number 5, line XY and point T are contained in plane P. Contained, think of a container. It has to be inside the plane. So are both line XY and point T on the plane? And the answer is false. All right, let's look at number 11 while we're up here. Given that y is between x and z, xy is 3a, yz is 14, and xz is 5a minus 4. Find xz. So the first thing we need to do is take this picture and write our geometric equation. So our parts are xy and yz, and our whole is x to z. So the equation would read xy plus yz equals xz. Please show the geometric equation. And then substitute to show your algebraic equation. So 3a plus 14 equals 5a minus 4. Now, let's follow our algebra steps correctly. So I would subtract 3a on both sides, which would leave me with 14 is equivalent to 2a minus 4. Then I would add 4 to both sides, which would give me 18 is equal to 2a. Then divide both sides by 2, and you would get 9 is equal to A. Then go back up and read the instructions. It wanted us to find xz. So xz was equivalent to 5A minus 4. So that means substitute 9 for A. So 5 times 9 minus 4. 5 times 9, 45. 45 minus 4 is 41. Number 12. On a number line, point R is at negative 30. Point T is at 96. What coordinate is the midpoint of RT? So the midpoint formula is x sub 1 plus x sub 2 divided by 2. All right, so let's just insert the current values. We have a negative 30 and a 96. So that would give me a 66 over 2 when you add those two, which would end up being 33. So 33 is the midpoint. And it is okay to have negatives as midpoints. It's okay to have decimals as midpoints. All right, for number 6 through 8, we're using this diagram right here. Number 6 reads, name 3 collinear points. Collinear means they're on the same line. So the only 3 points I see on the same line are J, K, and D. Number 7 says, is point D contained in plane X? Point D is located up here, so the answer is no. Again, contain means inside plane X. And number 8 is point M contained in plane X. Here's point M, and it also is not on the plane. For 13 through 16, we're going to use the number line as shown. The first one wants us to find DF, and when they list it without the bar, that means they want you to provide the measurement or the length. So we're going to use the distance formula. For the number line, it's absolute value of x sub 2 minus x sub 1. Yes, show the formula. So I told you guys you should start with the rightmost point first. So that's F. So let's put 5 and then negative 2 in parentheses and carry out the calculation. So it's 5 minus negative. So that's the same thing as 5 plus positive 2. So 5 plus 2 is 7. So the absolute value of 7. And so the distance is 7. Again, to find the midpoint, it's x sub 1 plus x sub 2 over 2. This time we're looking at C and E. And again, order doesn't matter. So C is at negative 4. E is at 2. Negative 4 plus 2 is negative 2. Negative 2 divided by 2 is a negative 1. So the midpoint of CE is -1. Number 15 says, if F is the midpoint of DG, find the coordinate of G. As you look at my number line, you don't see G on it. So the first thing we have to do is find the distance between D and F. So find DF. So again, we apply the distance formula for DF. F's at 5, D is at -2, and we found this one already, which is helpful. So we said the distance was 7. Since we're moving towards the right to get from D to F, we're going to keep moving towards the right to get to G. So we're going to add, since that's positive, but we're starting at F, and we're going to add 7. So that'd be 5 plus 7, which is 12. So G is located at 12. Number 16 wants us to find the coordinate that is 1/3 of the distance between A and F. So the first thing we have to do is find the distance from A to F, the total distance. So F is on the right at 5. A is on the left at -7. So that's the absolute value of 5 plus 7, which is 12. So that's the absolute value of 12. So that's 12. Our total distance is 12. The second thing you have to do is find the fractional distance. Take the fraction, 1/3, times the total distance, 12. So put it over 1 and multiply. So you would get 12 over 3, which is 4. So that's your fractional distance. Second, again, since we're moving to the right, we're going to add to the original starting value, which was A. So we're going to have A's value plus 4. So A was at -7, and then plus 4 more would put me at -3. So -3 marks the spot 1/3 of the distance between A and F. Number 9 wants us to find AB. So again, it's segment addition, so show the geometric equation. For this scenario, our parts are AB and BC, and our whole is AC. Now substitute in what given information you have. We don't know what AB is. We know that BC is 5.8, and we know AC is 13.2. Now we're going to subtract 5.8 from both sides to get AB by itself, which is what we're looking for. So that would be 7.4. Number 10 says, if a point on AC is chosen at random, what is the probability that the point is on AB? Express your answer as a percent. So again, the fundamentals of probability is always the probability of your desired. So we're desiring that the point is on AB out of the whole, which is AC. So that would be 7.4 out of 13.2. And it wants it as a percent. I'll show you without a calculator, just in case this is one of the non-calculator questions. So the tricks of decimal and fraction combinations is to change it to a whole number. At the top, I would need to slide the decimal one over. At the bottom, I would do the same. So it's technically 74 over 132. And then to get a percent, we need to do our long division. Where 132 is outside, 74 is inside. Obviously, 132 doesn't go into 74, so we put our decimal point and 0. And now I know that I've got to figure out how many times 132 will go into 740. So I know the leading term is a 7 and over here and a 1 here. So most likely it's going to be 7 times. So let's give that a try. So 7 times 2 is 14. 7 times 3 is 21 plus 1 is 22. And then 7 times 1 is 7 plus 2 more is 9. So 7 is too big. So let's try 5. All right, 5 times 2 is 10, 0. 5 times 3 is 15 plus 1 is 16. 5 times 1 is 5 plus 1 more is 6. Let's subtract. 0, 8, so 80. Add another 0. So how many times is going to 800? That would be 6. So 6 times 2 is 12. 6 times 3 is 18 plus 1 is 19. 6 times 1 is 6 plus 1 is 7. So that's 8 left over. Bring down a 0. It doesn't go into 80, so that means you would add a 0 up here and then the 0 and carry it on. So again, you want it as a percent. So we move the decimal, which is 0.560. You move the decimal 2 places to the left, to the right. So that's about 56%. 56% chance of landing on AB. Number 17, find the midpoint from point A to B. On a coordinate grid, it's x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2. Point A is negative 2, 4. Point B is 5, 1. So our x's are -2 and 5. Our y's are 4 and 1. Order does not matter. So -2 plus 5 is 3. 4 plus 1 is 5. You can leave them as improper fractions, which is totally fine, just in lowest terms, please. Or you can convert it to a decimal, so you should get 1.5 and 2.5. So knowing the formula, go ahead and work on number 18 on your own. Let's take a break right here and resume in just a moment.